Communication is the key to a successfully operating bus network. If we lose serial data, this may prompt multiple codes to set in multiple modules. So, let's look at the best way to address these U-type codes. A serial data fault within the electronic stability platform will prevent components transferring messages and cripple the network. These systems utilise CAN for real-time data transfer between the various modules. A short to voltage, ground, or between both serial circuits can cause a bus to go offline. Setting U0073 Bus B DTCs. Prior to diagnosing a communication fault, perform a battery load test. A weak voltage supply may be the cause of the communication codes. Don't forget to connect a battery maintainer to ensure stable voltage readings when performing voltage checks. Now that we know the system voltage is good, connect a scan tool to the vehicle's DLC and perform a module presence check. We do this because vehicles use different bus topologies. This should always be done to help isolate and localise the fault. Communication bus B offline means somewhere within the high-speed network the serial data wires have shorted together to ground or voltage. For that reason alone, we wouldn't need to test the modules for voltage or ground at this stage. Referring to our schematic, we can see this bus network uses a linear topology. We can test the ESP CAN network circuit resistance by connecting between terminals 12 and 13 of the DLC. Turn the ignition off and allow the bus to shut down. Connect a breakout box, set the meter to ohms and connect between the two terminals. 60 ohms should be seen in a correctly functioning network. If a substantially lower reading was displayed, this confirms the bus network has a short. Some OEMs may require us to backprobe at a module to measure the total network resistance, as they may not be connected to the DLC. To determine where the short lies, we will need to test the serial data circuit for the correct voltage readings. Turn the ignition on and connect the black meter lead to terminal 5 of the DLC, and the red lead to terminal 12 of the DLC. Between 2.5 and 3.5 volts should be displayed. On an oscilloscope, the CAN high trace would look like this. Now move the red lead to terminal 13 of the DLC. Between 1.5 and 2.5 volts should be displayed. Again, on an oscilloscope, the CAN low trace would look like this. If when testing either serial data circuit the meter displayed 0 volts, then there is a short to ground in that circuit. To confirm a short to ground, place the red lead on terminal 16 of the DLC and the black on terminals 12 and 13 respectively. If battery voltage is seen in either, this confirms a short to ground within that circuit. As we don't know where the fault is just yet, the best place to start is by looking at the schematic and separating it into two halves. Referring to this vehicle bus layout, the steering angle sensor is in the centre of the network. Turn the ignition off and disconnect the steering angle sensor harness connector. We can now determine which side of the network will require further diagnosis. With the test lead still connected to the DLC, turn the ignition back on while watching the meter. If battery voltage is seen, this confirms a short to ground to be within this half of the bus network. Turn the ignition off and disconnect the end node. In this case, it's the ABS module. Turn the ignition back on while watching the meter. If the meter now displayed 0 volts, the short to ground is within the ABS module or a circuit from the ABS module. Turn the ignition off and perform a continuity test between the serial data terminal and all other terminals within that connector. If no fault is found, this confirms the short to ground is within the ABS module. Although a fault in this module would normally be associated with other ABS DTCs. However, if when disconnecting the ABS module, battery voltage is still seen, turn the ignition off and disconnect the next inline harness connector. Then, turn the ignition back on. If 0 volts is now seen, this confirms the short to ground is within this section of harness. But if the meter displayed battery voltage, the short to ground will be between the inline harness connector, DLC and the steering angle sensor harness connector. If we were using an oscilloscope, a short to ground would look like this. The same testing procedures can be performed when locating a short to voltage. If when testing either serial data circuit, the meter displayed battery voltage when connected between terminals 12 or 13 and ground, then there is a short to voltage in that circuit. Turn the ignition off and separate the bus into two halves. Turn the ignition back on while watching the meter. With the SAS sensor disconnected and the meter displaying 0 volts, this confirms the short to voltage is in the lower half of the bus network, or in the steering angle sensor. Move the red meter lead to the affected serial data terminal within the SAS harness connector. If the meter displayed 0 volts, the short to voltage will be in the SAS or a circuit from the SAS. Turn the ignition off and perform a continuity test between the serial data terminal and all other terminals within that connector. If no fault is found, this confirms the short to voltage resides in the steering angle sensor.
However, other steering angle sensor DTCs will normally be associated with this type of fault.
But if the meter displayed battery voltage when connected in the SAS harness connector, turn the ignition off and disconnect the end node. Turn the ignition back on while watching the meter. If the voltage dropped to 0, the short to voltage will be in the yaw rate sensor or a circuit from the sensor. Turn the ignition off and perform a continuity test between the serial data terminal and all other terminals within that connector. If no fault is found, the short to voltage will be internal to the yaw rate sensor. Again, this will log other yaw rate sensor codes. If voltage remained during the test, turn the ignition off and disconnect the next inline harness connector. Turn the ignition back on while watching the meter. If the meter displayed 0 volts, the short to voltage will be between the yaw rate sensor and the inline harness connector. But if the meter still displayed battery voltage, the short to voltage is between the inline harness connector and SAS harness connector. If we are using an oscilloscope to diagnose a short to voltage, this is what an affected trace would look like. If when testing either serial data circuit, the meter displayed identical voltage readings, the bus circuits may have shorted together. On a scope, the trace would look like this. To confirm this, turn the ignition off and perform a network resistance check across terminals 12 and 13. A meter reading substantially lower than 60 ohms will confirm a short exists. Looking back at the schematic, locate the centre of the bus network and separate into two halves. With a meter reading of 120 ohms, the fault must be within the lower section.
This is what we should see in this half of the network. The meter is measuring the value of the terminating resistor within the ABS module.
Move the test leads and attach them to the CAN high and low terminals within the SAS harness connector. If the meter now displays 120 ohms, the short must be within the steering angle sensor.
A short here will be associated with other SAS codes.
However, if the meter displayed low to 0 ohms, disconnect the end module or sensor. If the meter reading shows an open circuit, this confirms the short is internal to the yaw rate sensor.
Again, this would also be accompanied by other yaw rate sensor fault codes.
If the meter continued to display low to 0 ohms, disconnect the next inline harness connector while watching the display. If the meter now returns an open circuit value, this localises the short between the yaw rate sensor and inline harness connector. But if the meter still displayed low to 0 ohms, the short is between the steering angle sensor and the inline harness connector.
Understanding the steps needed to diagnose a bus circuit fault will save you time, headaches, and increase workshop productivity. Make sure you keep an eye out for similar training modules on bus circuits. Thanks for watching. See you soon.